Thanks for downloading this lecture. Today we're going to talk about the topic of real numbers. To begin with, we're going to start by talking about working with sets. A set is a collection of elements which satisfy some given rule. If a set has no elements, it's called the empty set or the null set. So if you know what rule defines your set, you can generate the set of numbers that belong to it. There are two general methods for describing a set. The first method is called the roster method. In the roster method, you simply list every element of the set. So for example, we have D equals the set of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we've listed each number that's a part of the set. The other method for listing a set is called set builder notation, or the set builder method. So for this method, what you're going to do is you're going to write the rule for your set. So we have in brackets, the brackets denote that this is a set, the set of numbers x. The vertical line means such that, so x such that x is a digit. Set builder notation is really useful if you have a set of very large numbers where it would take you a long time to list every single element. So let's do an example where we're going to write out a set. The phone number for the math department at NC-A&T is 285-2033. Given that information, we want to write the set of numbers that are represented in the math department's phone number. And we're going to do this both using set builder notation and using roster notation. So first we're going to write the set in set builder notation. Remember, set builder notation just basically lists the rule that you're using to generate your set. So for this example, we could write P is equal to the set of x such that x is a digit in the math department's phone number. And the second method is the roster method. So remember, the roster method, we just list out every element of the set. So if we look at the phone number, we see that the numbers that are there are 2, 8, 5, 2, 0, 3, and 3. But we only need to write each number once. So if I write them in order, my set would be P equals the set 0, 2, 3, 5, and 8. Those are the numbers that are represented in the phone number. Next, we're going to talk about subsets. The definition of a subset is as follows. If every element of A is also present in B, then A is a subset of B, denoted as follows. A with a sideways U and a line under it, B. Now, if two sets have the exact same elements, then they're said to be equal. And so then we would say set A equals set B. Now we'll talk about intersections and unions. The definition of the intersection of two sets, A and B, written A with an upside down U and a B, is the set of elements that appear in both A and B. So to find the intersection, you'll look at your two sets, A and B, and you'll pick out all of the numbers or elements that are common between the two. And then the union of two sets, A and B, written A with a cup or a U, B, is the set of elements that appear in either A or B. So to find the union of two sets, you're going to look at set A and you're going to look at set B, and you're going to write down every single element that appears in either one. So let's do an example where we're going to work with intersections and unions. Given the sets A equals 1, 3, 4, 5, and 9, B equals 2, 4, 6, 7, and 8, and C equals 1, 3, 4, and 6, find the following. A union B, A intersection C, and A union B intersected with C. We'll start by finding the union of A and B. So remember, union means all of the elements that are represented in either of the sets. So let's look at set A and set B, and we want to look at the numbers that are in either set. So if I look, is 1 in A or B? Is 2 in A or B? Write down all of the numbers that appear in either A or B. And so if we write down all of the numbers that appear in either A or B, we'll see that the union of A and B is the set of numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. So all of those numbers are in both, or are in either A or B. Next, we'll look at the intersection of A and C. So remember, intersection means the numbers that appear in both A and C. So look at set A and look at set C and figure out which numbers appear in both of them. You should have seen that the set of numbers that appear in both A and C are the numbers 1, 3, and 4. So since 1, 3, and 4 appear in both set A and set C, those are the numbers that make up the intersection of A and C. The last part of this example is probably the trickiest part because it's a compound statement. We want to find out the intersection of C with the union of A and B. So in order to do this, we want to take it one step at a time. First, we want to find out what the union of A and B is. Since that's in parentheses, we want to find that first. Now, fortunately, that was the first part of the example. So we know that the union of A and B are the set of numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we can look at that along with C to find the intersection. Remember, intersection is going to be the set of numbers that appear in both of them. So which numbers appear in both A union B and the set C? And you should have come up with the set of numbers 1, 3, 4, and 6. These are the numbers that appear in both A union B and in C. The last thing that we're going to talk about when dealing with sets is the universal set and complements. The universal set, denoted capital U, is the set of all possible elements. And the complement of a set A, denoted as A with a bar on top of it, is the set of all elements that are in the universal set but are not in the set A. So, for example, if we're given that the universal set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9, and the set A is equal to 1, 2, 3, 5, 7, 9, we should be able to find the complement of A, or A bar. So remember, the complement of A, or A bar, is going to be the set of numbers that are possible, so they're part of U, but they're not actually in A. So look at the set A and figure out which numbers are not there. And if we look for the numbers that are not in A, we find that those are 4, 6, and 8. Those are the only numbers that are possible, the part of U, but are not in A. So that would be the complement of A, or A bar. Now we're going to move on and talk about classifying numbers. The first set of numbers that we're going to talk about is the largest set, and those are the real numbers. Those are all of the numbers that you can plot on the real number line. Note that the set of real numbers is denoted by an R with a double leg. The real numbers can be split into two subsets. The first subset is the set of irrational numbers. Irrational numbers are numbers that cannot be expressed as a ratio or a fraction. Examples of irrational numbers include the number pi, the square root of 2, the square root of 3, or any decimal that doesn't terminate and doesn't repeat. If a number isn't irrational, then it's part of the other subset of real numbers, and those are the rational numbers. Rational numbers are numbers that can be expressed as a ratio or fraction. Examples of rational numbers are 2, 1/3, 0.25, and any decimal that terminates or any decimal that repeats. The set of rational numbers can be split up into further subsets. One subset of the rational numbers, which we'll talk about a lot in this course, are the integers. Integers are numbers that do not have a decimal or a fraction. So, for example, -3, -2, -1, 0, 1, 2, 3. These numbers don't have fractions or decimals, and so these are the integers. A subset of the integers are the whole numbers. The whole numbers are basically the non-negative integers. So 0, 1, 2, 3, 4, 5, so on and so forth. And finally, a subset of the whole numbers, which is also a subset of the integers and a subset of the rational numbers, are the natural or counting numbers. The natural or counting numbers are just the positive integers, the ones that you would think about counting with. 1, 2, 3, 4, 5, so on and so forth. So let's do an example where we're going to classify numbers within a set. If we're given the set A equals -6, 1/2, -1.333 repeating, 0, pi, 2, and 5, we want to identify which of those numbers fit into the following categories: the natural numbers, the integers, the rational numbers, the irrational numbers, or the real numbers. For the natural numbers, remember the natural numbers are the numbers that we count with. Those are the positive integers. So the only numbers in our set that are positive integers are 2 and 5. The integers are all of the numbers that don't have decimals or fractions. They can be positive or negative. So the numbers within our set, which are integers, are the numbers -6, 0, 2, and 5. The rational numbers are numbers that can be written as a fraction. So remember, integers are rational numbers because you can always write them as the number divided by 1. So for example, -6 we could write as -6/1, so it can be written as a fraction. That makes it a rational number. Also, any decimal that is terminating or repeating is a rational number. And anything that can be written as a ratio or fraction is a rational number. So from our set A, the rational numbers are -6, 1/2, -1.3333 repeating, 0, 2, and 5. The irrational numbers are those that cannot be written as a fraction or ratio. So the only one that we have in this set is the number pi. Remember, pi represents a decimal that goes on forever and ever for lots and lots of digits. So it can't be written, it doesn't terminate, so it can't be written as a ratio. So pi is our only irrational number. And finally, for the real numbers, all of the numbers that are in our set A are real numbers. So the set of real numbers, or the numbers that are real numbers, would be -6, 1/2, -1.333 repeating, 0, pi, 2, and 5, the entire set A. Next, we're going to talk about finding the approximations of numbers. We're going to talk about two types of approximations. The first is truncation. In truncation, what you do is you drop all of the digits that follow the specified final digit. So if the problem asks you to truncate to 4 digits, or 4 decimal places, you would count the 4 decimal places out, and then drop all of the numbers after that. The other method of approximation that we'll talk about is rounding. So for rounding, again, we'll find the specified digit, and then we'll look at the next digit over. So if we're asked to round to 3 decimal places, we would count the 3 decimal places and then look at the 4th decimal place. If the next digit is bigger than or equal to 5, then we're going to add 1 to our specified digit. If the next digit is less than 5, then we're going to truncate and just leave it the way that it is. Alright, so let's do an example where we're going to approximate some numbers. Approximate the following numbers to 3 decimal places by first, truncation, and second, rounding. The numbers that we want to approximate are 28.65319 and then 0.06291. And again, we want to approximate each of these to 3 decimal places by truncation and then by rounding. So first we'll truncate 28.65319 to 3 decimal places. If we count over 3 decimal places, that'll put us at the 3 that's highlighted in red. And remember, for truncation, you just drop everything beyond that. So the 1 and the 9 are just going to go away. So the truncated approximation would be 28.653. Next, we'll round 28.65319. Alright, so again, we count to the 3 decimal places, that's the 3 that's in red, and then we'll look at the next place, which is a 1. Now since 1 is less than 5, we'll truncate. We'll just drop the 1 and the 9 out and leave the 3 the way that it is. Now we'll move to the other number. We'll start by truncating 0.06291. Again, we count 3 decimal places, that puts us at the 2 that's highlighted in red. And since we're truncating, we will just drop the rest of the numbers. So the 9 and the 1 will go away. So the truncated approximation is 0.062. And finally, we will approximate 0.06291 by rounding, again we go to 3 decimal places, that's the 2 in red, and when we round we look at the next number. So the next number is a 9. 9 is greater than 5, so we will round the 2 up to a 3. So the rounded approximation is 0.063. Next, we're going to talk about using operations to simplify and combine numbers together. So there are some basic operations that you probably are already familiar with, but there's a table here that expresses what the operation is, how we would write that out in symbols, and some sample words if you were dealing with word problems. So the first operation we'll deal with is addition. Addition can be written A plus B. And the sample words that make you think that you're dealing with addition are sum, A plus B, or B more than A. The next operation is subtraction. We could write subtraction as A minus B. And some sample words that tell us we're dealing with subtraction are difference, A minus B, A less B, or B less than A. Note that those last two examples, A less B and B less than A, are very similar. It just depends on how things are worded. If you have 5 less 2, that means 5 subtract 2. But if you have 5 less than 2, that means you subtract 5 from 2. The next operation is multiplication, which we can write AB, meaning A times B, or we could do AB with parentheses around them. The sample words that tell us we're dealing with multiplication are product, or A times B. Next we have division, which we would write as A divided by B, or A over B. And the sample words that tell us that we're dealing with division are quotient, or A divided by B. And then the final operation is equality, or equals, and that is written with the equal sign. And the sample words that tell us that we're dealing with that are equals, or is. So let's do a couple of examples where we're going to take some words and write them in terms of symbols to express the operations given. The first that we want to do is the difference 2 less y equals 6. Now remember, the order 2 less y is very important. And so written in symbols, this would be 2 minus y equals 6. Next, we have the sum of 3 and z is the sum of 2 and 2. So remember, sum means addition, and is means equality, so the sum of 3 and z means 3 plus z. Is would say write an equal sign, and the sum of 2 and 2 gives us 2 plus 2, so we could write this as 3 plus z equals 2 plus 2. And we could simplify that 3 plus z is equal to 4, but we just want to get the hang of writing symbols out from words. Now we want to talk about evaluating numerical expressions, specifically using the order of operations. So when you're given an expression to evaluate, an expression that contains many different operations, the order in which we do those operations are very important. One way to remember the order that we do them is using the acronym PEMDAS. You might have learned this as Please Excuse My Dear Aunt Sally, or something to that effect, where each of the letters PEMDAS in PEMDAS represent an operation that you would do in order. The first letter in PEMDAS is P. This tells us that we want to do anything that's in parentheses first. So the very first step to simplifying an expression is to simplify whatever's inside the parentheses that may be present. Next we have the letter E, which stands for exponents. So after we clear our parentheses, we'll want to evaluate any exponents that we may have in our expression. Next we have M and D, which stand for multiplication and division. And multiplication and division can be done at the same time, but it's important that you go from left to right. So you'll do all the multiplication and division going from left to right. And then finally we have A and S, which stand for addition and subtraction. And again, we can do addition and subtraction at the same time, keeping in mind that it's important to go from left to right. So go from the left of the expression to the right of the expression. So let's do an example. Evaluate the following expression. 2 times bracket 8 minus 3 parentheses 4 plus 2 close parenthesis close bracket minus 3. So if we want to evaluate this, again we want to look at the order of operations. The order of operations says we need to clear our parentheses first. So we're going to start by simplifying what's inside the square brackets. So specifically, we're going to start with the parentheses inside the square brackets. If we add the 4 and the 2 together inside those parentheses, that's going to give us 6. So inside our square brackets, we now have 8 minus 3 times 6. So next, we'll do multiplication within the square brackets. We need to simplify 3 times 6. And 3 times 6 is 18, so now inside the square brackets we have 8 minus 18. So the final step to simplifying what's inside the square brackets is to do the subtraction there. So 8 minus 18 gives us negative 10, and we've completely evaluated everything inside the square brackets. So now our expression is 2 times negative 10 minus 3. So we can continue going down our order of operations. We've cleared the parentheses, so the next thing we're going to do is multiplication. 2 times negative 10 is negative 20. So we have negative 20 minus 3. We can combine those together using the rules of addition and subtraction to give us our final answer of negative 23. So this whole expression simplifies to be negative 23. So let's do another example where we want to evaluate the expression using the order of operations. We want to simplify 2 minus 4 divided by 5 minus 3. Okay? In order to simplify this, we need to treat the numerator and denominator as if they are individual expressions. So we're going to put those in parentheses. So that gives us parentheses 2 minus 4 divided by parentheses 5 minus 3. So going through our order of operations, we first need to evaluate what's inside the parentheses. And we can do both of those at the same time. If we evaluate 2 minus 4 in the numerator, that gives us negative 2. And if we evaluate 5 minus 3 in the denominator, that gives us positive 2. So we're left with negative 2 divided by 2. We've cleared our parentheses, so the next thing we want to do is go on to multiplication and division. So what do we get if we divide negative 2 by 2? Dividing negative 2 by 2 gives us negative 1. And so that's the expression simplified. The simplification of this expression is negative 1. Next, we want to talk about the least common multiple and least common denominator. To find the least common multiple of two or more numbers, what we want to do is list the multiples of the numbers that were given and find the smallest one that they have in common. For example, let's find the least common multiple of 6 and 8. We'll start by writing down the two numbers whose multiples we want to find, 6 and 8. Next, we'll list out the multiples of 6. Now remember, multiples are just what you would get if you multiply 6 by numbers 1, 2, 3, 4. So the multiples of 6 are 6, 12, 18, 24, and 30. And then we'll list out the multiples of 8. Those are 8, 16, 24, 32. So the least common multiple will be the smallest number that they have in common, and if we look at our list, that number will be 24. So 24 is the least common multiple of 6 and 8. The least common multiple is important in finding the least common denominator. The least common denominator is needed to add or subtract fractions and can be found by finding the least common multiple of the denominators present. So let's look at an example. We want to add together the fractions 1/6 plus 5/8. Now remember, in order to add fractions together, you need them to have the same denominator. So we need to find the least common denominator. And the least common denominator is simply going to be the least common multiple of the denominators that you have. So we have the denominators of 6 and of 8, which we found out in the previous example, the least common multiple would be 24. So we need to transform our fractions so that they have that common multiple as a denominator. So if I have the fraction 1/6 and I want to have a 24 in the denominator, I need to multiply the denominator by 4. But I can't just multiply the denominator by 4 because that'll change my number. So I need to multiply the numerator by 4 as well. So if I multiply 1/6 by 4 over 4, which is the same thing as 1, so things don't change, that will give me a fraction that has a denominator of 24. Similarly, if I multiply 5/8 by 3 over 3, that will give me another fraction that has a denominator of 24. So if I multiply those together and simplify, 1/6 times 4 over 4 gives me 4 over 24, and 5/8 times 3 over 3 gives me 15 over 24. So now I have a common denominator. All I need to do is add the numerators together, and I'll find that 1/6 plus 5/8 is equal to 19 over 24. Finally, we're going to end this section on real numbers by talking about the properties of real numbers. These are properties that we're going to use throughout this course to solve problems and to evaluate real expressions. We'll start with the properties of equality. The first property of equality is the reflexive property, which can be written as A equals A. This basically just says that any number is equal to itself. The second property of equality is the symmetric property that says if A equals B, then B equals A. So essentially, the order that you write them with the equal sign doesn't matter. The third property of equality is the transitive property that says if A equals B and B equals C, then A has to equal C. And finally, the fourth property of equality is the substitution property that says if you know that A equals B, then you can substitute B into any expression for A. Next, we'll talk about the commutative property of addition and multiplication. The commutative property of addition says that A plus B equals B plus A. So essentially, the commutative property says that for addition, the order doesn't matter. So an example that shows this, if we look at 2 plus 3, that's equal to 5. But if we switch the order around and do 3 plus 2, that's also equal to 5. So this shows the commutative property of addition. The commutative property of multiplication basically says the same thing. If I have A times B, that should equal B times A. So the order doesn't really matter for multiplication either. And an example that illustrates the commutative property of multiplication. If I take 2 times 4, that equals 8. But if I switch the order around and do 4 times 2, that also equals 8. Next, we'll talk about the associative property of addition and multiplication. The associative property of addition says that if you have the quantity A plus B plus C, that equals A plus the quantity B plus C. So when we're dealing with addition, the placement of the parentheses doesn't really matter. So an example that illustrates the associative property of addition, if we take the quantity 4 plus 6 plus 2, well, 4 plus 6 is equal to 10, and 10 plus 2 is equal to 12. But if we move the grouping from the 4 plus 6 to the 6 plus 2, and we look at 4 plus the quantity 6 plus 2, well, that would give us 4 plus 8, which is also equal to 12. The associative property of multiplication is very similar, saying that the order of our grouping doesn't really matter. If we take the quantity A times B and multiply it by C, that'll be the same thing as A times the quantity B times C. And an example of this, if I look at 3 times the quantity 2 times 4, well, 2 times 4 is 8, so 3 times 8 is 24. But if I move the grouping to be the quantity 3 times 2 times 4, well, 3 times 2 is 6, and 6 times 4 is 24, so we see it's the same thing. Next, we have the distributive property, which states that if you have A times the quantity B plus C, you can distribute the A throughout to get A times B plus A times C. And note that the distributive property will go both ways, so if you have AB plus AC, you can pull the A out in front to rewrite it as A times B plus C. So here's an example of the distributive property. If you have 2 times x plus 3, you can distribute the 2 throughout the parentheses to give you 2 times x plus 2 times 3, and then you simplify that to give you 2x plus 6. And an example that goes the other way, if you're given 3x plus 5x, well, we have an x in both terms that we can pull out, and so we would have 3 plus 5 times x, which gives us 8x. Next, we have the identity properties. The first is the additive identity property that says that any number plus 0 is equal to itself. So 0 plus a will give you a. And we also have the multiplicative identity property that says that any number times 1 will give you itself. So 1 times a results in a. Next, we have the additive inverse, which states that negative a plus a is equal to 0. So a and negative a are opposites, and if you add them together, they cancel out. And we have the multiplicative inverse, which says that if you multiply a times 1 over a, or 1 over a times a, they will cancel each other out and give you 1, assuming, of course, that a is not equal to 0, because we can't have a 0 in the denominator. The quantity 1 over a is called the reciprocal. So if you multiply a number by its reciprocal, they will cancel each other out and give you 1. Next, we have the difference of two numbers, which can be rewritten using addition as follows. A minus b is the same thing as a plus a negative b. Similarly, for a quotient, we can rewrite the quotient a divided by b as a times 1 over b, again assuming that b is not equal to 0. We have the property of multiplication by 0, which states that any number multiplied by 0 will give you 0. And we have a couple of division properties. The first says that 0 divided by any number is going to give you 0, and any number divided by itself, so a divided by a, will give you 1, again assuming that a does not equal 0. We have some rules of signs that we'll be using. The first says that a number times the opposite of another number will equal the opposite of the product of the two numbers. So a times minus b will equal minus ab. Similarly, minus a times b will give you minus ab. Third, we have minus a times minus b equals ab. So the two minus signs will cancel each other out. Fourth, we have minus a equals a. So again, if you have two negative signs, they will cancel each other out and make a positive. Fifth, a divided by negative b, or negative a divided by b, will give you negative a over b. So one positive and one negative will result in a quotient that is negative. And lastly, the quotient of two negative numbers, negative a over negative b, is the same as the quotient of their positive counterparts, a divided by b. So again, the negatives will cancel each other out. We have a couple of cancellation properties which we will use fairly regularly throughout this course. The first says that if you have a product AC that equals a product BC, the C's can cancel out from both sides, leaving you with A equals B, assuming that C does not equal 0. And the second is similar, says that if you have A times C divided by B times C, again, the C's can cancel each other out, leaving you with A divided by B, assuming that b doesn't equal 0 and c doesn't equal 0. So let's look at a couple of examples that use these cancellation properties. First, we have 3x equals 12. In order to use the cancellation property, we want to rewrite 12 so that it has a factor that's common with 3 times x. So we can rewrite 12 as 3 times 4. So we have 3x equals 3 times 4. The 3 that is common on both sides of the equation will cancel out, leaving us with x equals 4. For a second example, we want to examine the fraction 4 divided by 12, which we can rewrite as 4 times 1 in the numerator and 4 times 3 in the denominator. The 4, being a common factor in both the numerator and denominator, will cancel out, leaving us with 1 divided by 3. Or 1/3. Next, we have the zero product property. This property is going to be extremely important when we start talking about factoring and solving equations. And the zero product property states that if you have the product of two numbers a and b, and that product equals 0, then you know that either a equals 0, or b equals 0, or they both equal 0. And the final property of real numbers that we're going to talk about in this section is the arithmetic of quotients. First, if you have the addition of two quotients or fractions, a divided by b plus c divided by d, remember in order to add them together you need a common denominator. So you could multiply the a and the b by d and the c and the d by b to give you ad over bd plus bc over bd. And once you have that common denominator, you can add the numerator together to give you AD plus BC over BD, assuming that B and D are both not equal to 0. Multiplication of quotients is a little bit more straightforward, maybe a little bit easier. If you have A divided by B times C divided by D, all you're going to do is multiply straight across. So multiply your numerators together to give you AC, and multiply your denominators together to give you a denominator of BD. And again, B and D cannot equal 0. Lastly, we want to look at the division of quotients, or the quotient of quotients. So if you have A divided by B divided by C divided by D, the way that we deal with this is we multiply by the reciprocal of the denominator. So since C over D is in our denominator, we're going to multiply by its reciprocal, which would be D over C. So A divided by B divided by C over D is the same thing as A divided by B times D over C. And again, for multiplication, we're just going to multiply straight across. So this will give us AD over BC, assuming that B, C, and D are all not 0. So let's do some examples where we're going to deal with the arithmetic of quotients. First, we want to add together 4 divided by 3 plus 1 divided by 2. So 4/3 plus 1/2. Remember, in order to add these, we first need to find a common denominator. So we'll multiply 4/3 by 2 over 2 and 1/2 by 3 over 3 to create a common denominator of 6 on both terms. Now we can just add the numerators together, so 4 times 2 plus 1 times 3, all divided by 3 times 2, and then we'll simplify to get our answer. So 4 times 2 is 8, and 1 times 3 is 3, so that gives us 8 plus 3 in the numerator, and 3 times 2 is 6, so that gives us a 6 in the denominator. If we add these together, we'll get 11 over 6 as our final answer. Next, we want to do an example where we deal with multiplication, so we want to multiply 5 divided by 9 times 3 divided by 10. Remember, with multiplication, you're just going to go multiply straight across. Multiply the numerators, and then multiply the denominators. So, if we multiply our numerators together, we get 5 times 3 is 15. And if we multiply the denominators, 9 times 10 is 90. So this is going to give us 15 over 90. But we can simplify that. We can divide a 15 out of both the numerator and denominator to give us a reduced fraction of 1 over 6. So 5/9 times 3/10 gives us 1 over 6.